Hello everyone. My name Orko myself, and today we'll be learning about cadence algorithm. What is cadence algorithm? Cadence algorithm is an efficient way to find the maximum subarray sum. So, we will be understanding today about cadence algo, and we will understand it in a easy way. This algorithm is very much handy because excuse me, this algorithm is very handy because in contest or like in online assessment or coding part, if you can remember this algorithm, finding the maximum subarray sum will be very easy, and its modified version are will be getting used very much. Using you need to use it in different problems by modifying this algorithm. So before modifying this, you need to know the basic, right? And it runs on big of in time complexity and big of one space complexity. So uh, this and the coding part is very less. The code will be 5 to 6 lines. So this is a very good algorithm. uh, we will look at the most naive or the brute force approach, then the better solution, and then we will come to the most efficient cadence algorithm. So without further ado, let's get started. Suppose we have been given an array 2, 3, minus 8, 7, minus 1, 2, 3. So this is my array. And what is my objective or what is my motive? Like, what is your objective in life? What is your motive in life? No one knows that, right? We are not sent in this planet with any objective. We are just making time passes, right? So, what is our objective in this thing? We need to return the maximum sub array sum here. Subarray, what is a subarray? First, you need to understand this. Subarray is a contiguous part of an array. Like, suppose this is my array. This can be a subarray. This can be a subarray. This can be a subarray. If I will tell you that in this example, 3 minus 8, 7 minus 1, this is a subarray. Yeah, it is a subarray. If I tell 2, 3, 2, 3, no, this is not a subarray. Why not? Because it is not contiguous part of an array. Here, some partition or some gap is coming, right? Here you can see 2, 3. Here we will see. But we need to take something that is contiguous or continuous. So we have got to know what is a subarray. And we need to find the maximum subarray sum. I will write it here. Max subarray sum. My handwriting is like awful. Please bear with that. Okay. So how can we do that? Suppose you are given this array. I'm not writing elements. Not make it too much complex. So how can we check? How can we get all the subarrays in this? What will be the most naive or most brute force approach to this problem? This can be a subarray. 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 Okay, like this. This can be a subarray. This can be a subarray. This can be a subarray. This can. See here you can see something that when we are on an element, we can find the subarray like this. We will be running two for loops. Subarray will be I to j. My subarray will be from I to j. For the first time, this subarray will be considered. For the next time, this subarray will be considered. When I will be here, this subarray will be considered, then this subarray will be considered. We are not going backwards. Why we are not going backwards? Because we are not going backwards because, see, when we are here, we will only consider the forward ones. Because we are not considering this backward subarray when we are here, because it is already considered. How it is already considered? It is already considered when you are here, you have already considered this subarray. So it has got already taken up by the previous one. So we are just getting forward, and by this way, using two for loops, you can check for all subarrays. And how you will check? You will check it like this. This is my subarray, suppose. Is I and j. I represents the starting point and j represents the ending point of the subarray. Suppose this is I, this is j. And in this thing, I need to calculate. Suppose here there is no space, so I'm writing it. Excuse me, at this place. You need to again run a for loop from I to j, from the starting point to the ending point. For suppose L is equals to I, L is lesser than equals to j, L plus plus, sum is equals to 0. Let's take the sum array of I, array of L, sorry. Okay, so now we are getting every subarray, and for every subarray we are calculating the sum. And if after calculating the sum, if my sum is greater than the max, then just update our max equals to sum. So like this way, using the most brute force approach, you can find the maximum subarray. And at first you will be initializing the max with minus infinity. Minus infinity means in Java basically integer dot mean value, or if you're using long dot mean value, like that. Okay, if my sum is greater than max, why I haven't taken 0 here? My universal max, suppose like in cricket we have got universal boss Chris Gale. Here is universal max, but Chris Gale is not minus infinity initially. Okay, so why I am taking minus infinity? Let's understand this thing. Suppose we have been given a array -7 and -2. For this way, if I will update my universal max as 0, then my sum will never be greater than my max. And here the sum will be negative, right? Both sum will be negative, individual sums will be negative, and my maximum sum will universal max will be 0, and that is a wrong universal max. So we are using minus infinity here. Okay, for the next time, let's analyze the time complexity. If I will analyze the time complexity is big O of, for this loop it is n. Again you are going from, for the I loop you are traversing once, for the jth loop you are again traversing from like this thing to the next part of the array, again n into, for calculating the sum you are again traversing some part of the array, and in the average case you can take it as n. So it is the worst case time complexity of big of n u. Oh my god, it is very much like costly, right? Big of n cube. If the constraints are very huge, you can't use this. So what can we do here to save our time? Can we is there some way to get the sum of a subarray in an array at constant time? Can we do that? Is it possible or not? Okay, let's check it. Is it possible or not? So our next job is to get rid of this loop, how can we get the sum of some part of the array? Suppose 1 2 3 4 is our array, and how can we get the sum of any part of the array? Suppose this part, suppose this part, suppose the whole part, suppose this part, at a constant time. I will just call something and I will get. Here I will be using pre-computations. Pre-computations will be used here. Pre-computation means I will calculate previously the suffix and the prefix sum of the array. What is suffix and what is prefix sum? Okay, 1 2 3 4. Let's check here. Suppose this is my array. I will be making two more arrays. It is prefix sum array and it is suffix sum array. SS, not like anything else. And this is PS, not PS5. So what is prefix sum array? Prefix sum array means up till this part, what is the sum? So here if I will make the prefix sum array here it will be 1. At this part, when you are this part, what is the sum up till this part? 2 plus 1, 3. Up till this part, what is the sum? 3 4 5 6. Up till this part, what is the sum? 4 7 8 9 10. Or we can add it like this: 6 plus 4 10. And for calculating the suffix sum array, suffix sum means we are like suffix, we are coming from the back. This is 4, this is 4 plus 3 7, this is 7 plus 2 9, and this is 1. Right, up till this part, what is the sum? 9. 4 plus 3 plus 2. Till this part, what is the sum? 1. 4 plus 3 plus 2 plus 1. Okay, we have got the prefix sum and the suffix sum. So now you have got both of this array. Now if I tell you, tell me the sum of starting point and ending point. 0 1 2 3. Okay, these are the indexes. It may look very dirty or concept. These are the indexes, IDX index. So I want you to tell me the sum for index 1 to 2. How can you do that? How can you do that? You can do one thing here. What you can do? Indexes, right? We have got the indexes. We have got the starting point. We have got the ending point. 3 4 5 6. Okay, let's. Okay, how can you like give me this subarray sum? How can I give you? So I have to pre-compute the whole array sum. The whole array sum is 10 here, and before the starting point, give me the minus prefix sum before the starting point. That is I minus 1 plus the suffix sum of I. Sorry, this is I means start plus 1, and this is start. This is end plus 1. Start minus 1 and end minus 1. Remove from the whole part. Remove this part and remove this part, and you will get this sum. It can be a pretty complex, but let me make you understand this thing. Suppose we have got, with using some more element, you can visualize it. Suppose this is I and this is J. You need only this part. And what you know that what is prefix of, like what is prefix sum of I minus 1 contains? Prefix sum of I minus 1 contains the sum up till this one. Okay, battery is pretty much less. Okay, It is prefix sum of I minus 1 contents the sum up till this much. And what is suffix sum of j plus 1 contents? Suffix sum contains the sum up till this one. So from the whole array sum, if I will subtract this part and this part, I can get this subarray sum. And using the concept of prefix sum and suffix sum, you can get the the sum of a subarray at constant time complexity. So here we will pre-compute the prefix sum and the suffix sum, and we can get at constant time complexity. So although our space complexity of big of 2n, but using space, if you can reduce down your time, do that. It is much more convenient, because nowadays we can like use a lot of space. Computers are coming up as 1 TB, 2 TB, but time is very costly. So time complexity of big of n square. We are not again traversing the whole array to get the subarray sum, and my space complexity is big of 2n. Why 2n? Because we are using suffix sum array and prefix sum array, right? This part. You can do one thing also. What is that thing is, you can do one thing that, okay, you don't have to like use a prefix sum array here. You can do it, a suffix sum array here. We can do it only using a prefix sum array, or you can only use a suffix sum array. I will show you using only a prefix sum array. So suppose this is our starting point and this is our ending point, and I need to calculate this part of the subarray. You get the suffix sum of this one and you get the suffix sum of this one. So the prefix sum of start minus 1 and plus the prefix sum of end up till this one and up till this one. And if you will subtract this bigger, like this part, from this part you will get this part. So prefix sum of end minus prefix sum of start minus 1, you will get the subarray sum. And you can use the same concept using suffix sum also. If you want to use suffix sum, I will show you. Suppose this is my start, this is my end, and you can take this one and you can take this one. If you will subtract this from this bigger part, if this gets subtracted, we are only left with this much part. So you can use this to get any subarray sum at a constant time using this simple pre-computation. And this concept of suffix sum and prefix sum is very important, because it will be used in so much questions to reduce your time complexity, and their modified version will also be used. Now our time complexity is big of n square and our space complexity is big of n. Now we need to reduce it to big of n and big of 1 using Kadane's algorithm. So now we are coming to our main topic, right? So what the topic says, so our is 2, 3, minus 8, 7, minus 1, 2, 3. Okay. So I will make a dry run, and understanding the dry run, you will get the concept of Kadane's algorithm and how it works. We will take a variable as sum. 0. Okay, maybe it is your current sum. You can okay, you can say, and take again this one as max sum. Max sum we are taking minus infinity. I have already explained that why we are taking minus infinity as max sum. Okay, now we will be iterating the whole array. What is my first element? My first element is 2. Okay, so my sum is 2. Is my sum greater than my max sum? Yes, my sum is greater than my maximum. So my maximum will at last store the maximum subarray sum, and you will return max sum from the function that the maximum subarray sum is calculated. Is 2 is greater than minus infinity? Yeah, 2 is greater than minus infinity. So my maximum sum is 2. Next, go to the next iteration. What is my sum now? 2 is already stored here plus 3, that is 5. And is 5 is greater than 2? Yeah, 5 is greater than 2. So now my maximum is 5. We are getting to the next element. Now I am here. Minus 8. Okay. 5 minus 8, minus 3. Minus 3. Is minus 3 greater than maximum? No, minus 3 is not greater than. So it will not be updated. But before going on to the next element, see one thing. One thing is that suppose I am taking minus 3 as my sum and I am adding it to the next element. It is sure shot that you will get something like, suppose minus 3, 10, 2. Suppose I will take minus 3 for the next element. Suppose I take it and I will add it to 7. It will be 4, right? It will be 4. But here you can see that if I have taken only 7, then my my sum will be larger. So here you can see one thing, that it is not of any use to take some negative part as sum, to take some negative part, to take some negative one, because it will eventually reduce my sum. Look at this example. Suppose I will take this example. Look at this one. What will be the maximum sum? 12. And here my sum is minus 3 at first, and max sum is minus infinity. Minus 3 is greater than minus infinity. At sum it is minus 3. But for the next iteration, I don't want to take minus infinity. I don't want it. Why I don't want it? I want anything which is greater than 0. If it is 1, then I would take it, because if I would take 1 and I would add up it to the next element, it will increase my sum. But I would take something minus, then add up to my next element, it will decrease my sum. And I will not take it. As it is minus, for the next iteration, I will make sum as 0. I am here 10. Sum is 10 now. 0 plus 10, 10. 10 is greater than minus 3. Yeah, 10 is greater than minus 3. Max sum is 10. And I am going to the next element. Here I am not making sum as 0. Why am I not making minus 0? Because here I have got something positive and I need to carry on. I need to propagate it. And I will add up 10, like 2 plus 10, it will be 12. And as maximum is greater than sum is greater than maximum, it will be 12. So this is Kadane's algorithm. We will only take the positive part from the next one. Like suppose you are meeting many people. You are meeting n number of people in a day, and you take everything. You take the positives, you take the negatives from people. Everyone has some pros and some cons, right? Suppose there is a very intelligent boy in your class and you meet him, like he have got very good problem solving skills, and stuff like that. He had great communication skills, etc., etc. These are his positive, but he actually smokes, he actually drinks, he is addicted to some bad things. These are the negatives. If you will take then positive, then it is good for you. But if you will take the negatives, then it will impact you, then it will degrade you. You are like you are taking the negatives, like okay, this boy also drinks, this boy also smokes, then why it is bad for us? So like that, you need to avoid the negatives. And in Kaden's algorithm, you can remember the story that Kaden is a very like very good human being as well. Like uh, see, why I'm telling this story is because we human beings can't remember uh, everything. Like in our Vedic Purans or stuff like that, everything, every concept, every understanding, every complex stuff is told us in a way of story. Why? Because human beings can remember stories, and human beings can't remember numbers, can't remember algorithms or what is the process. Human can remember story. So here you can understand that Kaden is a very good human being, and he has a very good network of people, and he meets like 10 to 12 people every day. But he has made a law in his life: he will only take the positives from them, not the negatives. So whenever someone comes with negatives, he make it to zero, and then he propagates. He don't take the negatives. If someone suppose there is a very intelligent guy, his IQ is very high, but he is not honest. This is negative. And here you can see his negative is greater than his positive. As his negative is greater than his positive, his total value becomes negative. And as his total value becomes negative, Kaden will not include him in his network. Like that way, we will be considering this algorithm. So minus 3, we will not consider minus 3. Why will not consider minus 3? Because we will set it to 0 and my maximum is 5. And when we come to this part, when we have come to this part, let's check that. Now my sum is 7. 7 is greater than 5. Yeah, 7 is greater than 5. When I have come to here, minus 1. 7 minus 1 is 6. See, here I will take this minus 1 because his overall, the person, overall behavior is positive, and this my overall behavior is positive because it can make in the future some betterment in the subarray sum. Here I will take it, and 6 is greater than 7. No, I'll again iterate it. 2 is I will add it to 2. 8. 8 is greater than 7. Yeah, 8, and I will get up to here. 3, I will add 3. 8, 9, 11. 11 is greater than 8. Yeah, 11. So my maximum is 11, and now I will see the result. Yeah, the largest sum is 11, and the subarray is this one. This one is the subarray. So this is Kadence algorithm. You will just go. If I will write the code is very much simple. For we are traversing the whole array, and what you are doing, we have initialized the maximum as minus infinity and the sum as 0. We are sum plus equals to e of I. We are adding the element which we are currently in, and if my sum is greater than maximum, then max sum is equals to sum. If my sum is lesser than 0, that means, or you can say if my sum is negative, then I don't need to take it. Then I will leave it. Then I will make my sum as 0 for the next iteration. And this way, by using these 3-4 lines, you can get the maximum subarray sum from any array at a time complexity of big of n. You can see it is running big of n, pretty simple. And space complexity big of 1, because we are not using any extra space here. So this is the whole story of Kadane's algorithm, and I hope you got it, or I hope you understand it. And bye bye, thank you. Take care.